Good morning, guys. So today we'll be talking about synthetic division. Okay. Synthetic division, remainder theorem, and zeros of polynomial function. So first of all, I want to tell you something about the division algorithm. Okay. So division. So division algorithm. Okay. So now, hey, let's look like suppose you have a number 17 and you want to divide by 3 in arithmetic, right? So how do you divide this? So 3 times? How do you divide 17 by 3? 3 times 5, it's going to be 15, right? And 17 minus 15, what is this? 2, right? So do you know what is 3 here? What's the name of the 3? Or what does 3 represent? You guys know this is divisor, is that right? Right? Divisor is 3, right? Do you know that? And then what is this 17? Huh? What is 17 called? Dividend. So dividend is 17. And what is this 5? 5 is the quotient. And what is this 2? 2 is the remainder. Is that right? So now, if you look here, this dividend, this 17 is equals to 3 times 5, 3 times 5 plus, what is the remainder? 2. That makes sense? Because 3 times 5 is 15, 15 plus 2 is 17. Is that right? Now, what is this 17? This is dividend. What is this 3? This is divisor. And what is this 5? This is quotient. Plus, what is this 2? Remainder. You see that? So dividend equal to divisor times quotient plus remainder. So this is called division algorithm. That makes sense? Yeah. So now, this is for arithmetic, okay? So if you want to do the same thing in algebra, so let's say you have a dividend fx, okay, and you want to divide this dividend by what? Divisor gx, right? Right? And then you have a quotient qx, is that right? And you multiply gx and qx, so that will be gx times qx. And then you subtract that, you will get a remainder rx. Are you with me? Right? This is divisor. This is dividend. This is quotient. And this is what? Remainder. That makes sense? So now if you write down in this form, you see your dividend is fx and your divisor is gx times your quotient is qx plus your remainder is what? Rx. So this is the division algorithm. So now, let fx and gx be 2 polynomials, okay, with gx of lesser degree than what? Fx. the degree of gx is less than fx. So you have fx and gx be polynomials with degree of gx less than what? Fx. Okay? Now, you see, so this gx is of degree 1 or more. Okay? So the degree of gx is at least 1. 1 or more means at least the degree of gx is at least 1. Then there exists unique polynomial qx and rx such that fx equal to what? Gx times qx plus rx. That makes sense? And where this remainder rx is either 0 or the degree of rx is less than the degree of gx. You see what I'm talking? So that is the division algorithm. What did I say here? Let fx and gx be two polynomials. Fx and gx be two polynomials, right? And the degree of gx is less than what? Degree of fx, right? And the degree of gx is at least 1, okay? Then there exists unique polynomial qx and rx such that fx equal to gx times qx plus rx. And this rx is the remainder. Okay? The remainder is either 0 or the degree of rx, the degree of rx is less than degree of gx. That makes sense? Yeah. So this is a division algorithm. Okay? So now the synthetic division, guys. So if you want to use synthetic division, your divisor must be in the form of x minus k. Okay? If your divisor is not in the form of x minus k, then you cannot use synthetic division. Okay? So, are you guys with me? Just keep in mind, okay? Synthetic division. The divisor must be in the form of x minus k. Divisor, right, must be in the form of x minus k. If you want to use synthetic division, okay, must be in the form of x minus k. Otherwise, you cannot use synthetic division. Now look here, guys. So you have a polynomial, let's say, let's say you want to divide polynomial. You have a, let's say, polynomial fx equal to 3x cubed minus 2x squared minus 150. So this is your polynomial. You want to divide by, let's say, your gx, which is your divisor, is x minus 4. Okay? So now, let's use the long division. Okay? So, first of all, I want to use long division. So how do you divide this by this? By using long division. So you write down x minus 4 here, and then you have a 3x cubed minus 2x squared minus what, 150. Right? So the first step is you divide this first term of the dividend by the first term of the divisor. So this is 3x cubed and this is x. You divide 3x cubed by x, then you know this is 3x squared. Right? Is that right? And then you put 3x squared here and you multiply each term of the divisor by what? 3x square. That makes sense? So 3x squared times x, what is 3x squared times x? 3x cubed, right? And 3x squared times negative 4, negative 12x squared. Are you guys with me? Make sense? And then you see this is the division, so you change the sign here, okay? You change the sign. So this is going to be what? Negative, and this is going to be what? Positive. You guys know that, right? And now this 3x cubed, positive 3x cubed, and negative 3x cubed, you cancel them. And what is this? Negative 2x squared plus 12x squared. What will be this? 10x squared minus what? 150. Does that make sense? You bring it down, you know. You bring it down. So now, again repeat the similar process. So you have a 10x squared. This is the first term of the new dividend. This is your new dividend. So you have a 10x squared, and you divide this by what? X. So this is 10x. Right? So now you have a plus 10x here, and you multiply x minus 4 by 10x. So 10x times x is 10x squared, and 10x times negative 4 is negative what? 40x. Does that make sense, guys? Yes? 10x times x is 10x squared, 10x times negative 4 is what? Negative 40x. And now again we change the sign, so it will be negative, and this will be what? Positive. Right? And then this 10x squared and negative 10x squared, you can cancel them. Does that make sense? And now, hey, this is 40x, you write down 40x, and then you have negative 150 here, write down negative 150. Now, repeat the same process. This is your new dividend, okay? So you have a 40x over x. So you divide 40x by x, so that will be what? 40. Right? So now you have a plus 40 here. So now you multiply this 40 times x is 40x, 40x, and this 40 times negative 4 is negative 160, right? And you change the sign. So this will be negative, this will be what? Positive. Make sense? And then this positive 40x and negative 40x, you can cancel them. And this is negative 150 plus 160. What is this? This is 10. Now this 10 is the what? Remainder. This 10 is this is the remainder. And what is the quotient? This 3x squared plus 10x plus 40, this is the what? Quotient. Right? And what is this? This is the divisor. That makes sense? And what is this? What is this? This is the dividend. Dividend. Right? So now this is the long division method. And we can use synthetic here because your divisor, what is your divisor? This is x minus 4 is exactly in the form of x minus k. Is that right? X minus 4 is in the form of x minus k. So if you compare x minus 4 with x minus k, then you will get the value of k equal to 4, right? The value of k is 4. Does that make sense? So now, if you want to use synthetic, you write down the value of k here. This is 4. Okay? And then you list the coefficient of the variable. And one thing you have to know is it must be in a standard form. A standard form means in the decreasing power of the what? Variable. Like you see, this is x cubed, x squared, and so on. Is that right? But you got to be careful here because what is missing? Which term is missing here? We have a x cubed, We have x square, so we don't have what? X term here. Is that right? Right? X term is missing. So now what you can do here is you can rewrite this like this is 3x cubed minus 2x square plus 0 times x, which is 0, right? Minus 150. Make sense? So now, so this is k is 4, and now list the coefficient of x, okay? So what is the, coefficient of the, like a power of x, like what is the coefficient of x cubed? 3. What is the coefficient of x square? -2. What is the coefficient of x? 0. What is the constant term? -150. See that? So now, if you want to use synthetic, the first step is you bring down the first coefficient. You bring it down. Bring it down. 3. I'm using synthetic division here. You compare the divisor with x minus k, get the value of k, we put it here, right? And then we list the coefficients. What is the coefficient of x cubed? 3. What is the coefficient of x square? -2. What is the coefficient of x? 0. And what is the coefficient? What is the constant term? -150. And keep in mind, if any term is missing, you have to put the coefficient 0. Okay? So now you multiply this. 4 times 3. What is 4 times 3? 12. So you write down here. You see that? So -2 plus 12, it's going to be 10. Is that right? Right? And you repeat the same process, like 4 times 10, 40, right down here. So what is 0 plus 40? 40. See that? And then you multiply this. 4 times 40. What is 4 times 40? 160. Is that right? So you write down 160 here. So now -150 plus 160. What is -150 plus 160? 10. So this is the remainder. Make sense, guys? And you see here, what is the remainder here? 10. And what is the remainder here? 10. You see that? This match, right? So now, if you want to find the quotient, we denote this by qx, right? Qx. So the degree of quotient will be 1 less than the what? Degree of dividend. What is the degree of dividend here? What is the degree of dividend? 3. So what will be the degree of quotient? 1 less than 3, right? So that means 2. So the degree of quotient will be what? 2. So if you have an x squared term, then you will have an x term, and then you will have a constant term. Is that right? X squared terms, x term, and what? Constant term. Look here. Now what is the coefficient of x squared? 3. You write down 3. What is the coefficient of x? Plus 10. You write down plus 10. And what is the constant term? Plus 40. Plus constant term is what? 40. You see that? Constant term is 40. So what is the quotient now? 3x squared plus 10x plus 40. Look here, 3x squared plus 10x plus 40. So this is called synthetic division. But what you need to know is, if you want to use synthetic division, you have to have the divisor in the form of x minus k. Keep in mind that, okay? I think we got it, right? Yeah. So this is what the synthetic division, you know what I mean? Okay. Now, if you look here, it's pretty much use synthetic division to divide 5x cubed minus 6x squared minus 28x over 28x minus 2 over x plus 2. So divide and use synthetic, okay? Use synthetic division. So that is 5x cubed minus 6x squared. So you have a 5x cubed minus 6x squared minus 28x minus 2 over x plus 2. Guys, you see, what is the divisor here? What is the divisor? X plus 2, right? It should be in the form of x minus k. So is x plus 2 is in the form of x minus k? Yes? So can you compare x minus k, comparing x plus 2 with x minus k. What is the value of k? Yes, the value of k is negative 2. Remember, this x plus 2 is same as x minus negative 2. Is that right? Right? So the value of k is, this will give you the value of k is negative 2. So we can use synthetic. So this is negative 2. You write down negative 2 here, and then, so list the coefficient. And none of the term is missing here. We have x cubed, we have x squared, we have x, right? So you write down the coefficient of x cubed. This is 5. Coefficient of x squared, this is negative 6. Coefficient of x, this is negative 28. And the constant term, this is what? Negative 2. And now you bring down the first coefficient. You bring it down. So it's going to be 5. So negative 2 times 5, it's going to be negative 10. Negative 6, negative 10, you combine them, right? You combine them, it's a negative 16. And you multiply this negative 2. Are you guys with me? Negative 2 times negative 16 is, what is negative 2 times negative 16? Positive 32, right? And 28 plus 32, it's going to be 4. Are you with me? And then again, negative 2 times 4 is negative 8. And you combine them, this is what? Negative 10. Right? And so this is going to be the what? Remainder. This is going to be the remainder. That makes sense? So now, what will be the quotient? Can you tell me what will be the quotient? What will be the quotient?
Bring down all the numbers that you have there, right? And then you add the values.
Yeah. Yeah.
5x or
5x squared, yeah.
and then it's negative 16.
Negative 16x.
Negative 16x.
Yeah, and then constant term is what? 4. So you see what I'm talking, right? So look here. So the degree of dividend is 3. So the degree of divisor, the degree of the remainder must be what? What did I say? The degree of dividend is 3, right? Right? The degree of dividend is 3. The degree of quotient must be 1 less than 3. Is that right? So 1 less than 3 is 2. So you will have x squared term, you will have a x term, and you will have a what? Constant term. Is that right? Are you guys with me? Degree of dividend is 3. So degree of quotient will be 1 less than 3. 1 less than 3 means 2, right? So you will start with x squared term, and then there will be x term and the constant term. Now this is going to be the what? Coefficient of x squared. So this is 5x squared. And then this negative 16 will be the what? Coefficient of x. So this is negative 16. And then this 4 is the constant term. So you can simply write down plus 4. So this is the what? This is the quotient. You got it. Okay. So now, okay, you got that part. And this is like, we did that. So this is the special case of division algorithm, sometimes the remainder, like we'll have a number. Like in this case, what is the remainder? Number, which is -10, is that right? In this case, what is the remainder? +10, right? So in that case, fx will be equal to what? X minus k times qx plus what? R. So you have a special case of division algorithm. So what is the special case of division algorithm? You have a dividend fx. It has been divided by what? X minus k, right? And what is the quotient? Qx. And you see the degree of remainder. This is going to be x minus k times qx. And when you subtract this, you will have r. The remainder is a number in this case. You know that, right? Because the degree of remainder is what? Less than the degree of quotient. The degree of quotient is what? 1. Right? So that's why this should be a constant. And you can write down this as a dividend. This is dividend equal to divisor is x minus k times quotient is qx plus remainder is what? R. That makes sense? Are you guys with me? So now what you need to know is for any polynomial fx, right, and any complex number k, there exists a unique polynomial qx and a number r such that fx equal to x minus k times qx plus r. So this is the special case of division algorithm. Make sense? Okay. So, good. So this is a remainder theorem, guys. If fx is divided by x minus k, okay, then the remainder is equal to f of k. So remainder theorem. Remainder theorem. If the polynomial fx is divided by x minus k, if the polynomial fx is divided by x minus k, then the remainder is equal to what? Fk. Then the remainder is equal to Fk. Are you with me? Right? Right? So now I'll show you that, okay? It's so simple. So look at the same thing same problem we did, okay? Look here. So if you want to divide, you see, I erased that one. So now look here. So if you want to divide, let's say your fx is here, let's say 5x cubed minus 6x squared minus 28x minus 2 over x plus 2, right? Right? Oh, this is your fx, and this is your fx, and this is your what? X minus k. x minus k is this, so that will give you k equal to negative 2. You guys know that, right? K equal to negative 2 because this is x minus negative 2. Right? So now, do you remember the remainder we got last time? I think it's the negative 10 or negative 10. Okay, yeah. So now look here. If you use the remainder theorem, so according to remainder theorem, if the polynomial fx is divided by x minus k, then the remainder is equal to what? Fk. Right? What is the value of k here? What is the value of k? Negative 2. Is that right? Right? If we apply the remainder theorem, so your remainder is equal to Fk. Right? Right? So now that is going to be F. What is K? K is what? Negative 2. F of negative 2. Are you with me? So now you plug in negative 2 here. So this is, because this is your fx, right? So how do you evaluate f of negative 2? So this is your f of x. This is f of negative 2. So 5 times negative 2 to the power 3 minus 6 times negative 2 square minus 28 times negative 2 minus what? 2. Good? So now it would be what? So this is 5 f of negative 2 equal to 5 times, what is parenthesis negative 2 cube? This is negative 8. Is that right? Right? Minus 6 times, what is this? 4. Right? And negative times negative positive, 28 times 2 is what? 56 minus 2. Does that make sense? So now this f of negative 2 equal to 5 times negative 8, this is negative 40, negative 6 times 4 is negative 24, plus 56 minus 2. You got it? And now, so this is f of negative 2 equal to negative 40 minus 24 is negative 64, negative 64 minus 2 is negative 66, plus 56, this is equal to what? Negative 10. See that? So this is the application of remainder theorem. Okay? You got it, guys? Do you see the remainder is negative 10? Right? Okay. So this is remainder theorem. We did that. You can do that. You just plug in x equal to negative 3, right? To get the value of f of negative 3. You can do that. Hey, now the zero of a polynomial function. A zero of a polynomial function fx is a number k such that f of k equal to 0. So the real number 0 are the x-intercept of the graph of the function. And 0 is also called a root or solution of the equation fx equal to 0. So you understand that, right? Zero of a polynomial function. So a zero of a polynomial function is the number k, okay? A zero of fx, let's say fx is the polynomial function, is a number k such that fk equal to 0. So what does that mean? That means, let's say your polynomial function fx equal to x square plus 5x plus 6. So this is your polynomial function, okay? So if you plug in here, let's say if you plug in negative 3 here, what will happen? So this will be negative 3 square plus 5 times negative 3 plus what? 6. Right? Right? So now this is going to be, what is this? This is 9. What is 5 times negative 3? Negative 15 plus 6. Is that right? So what is 9 plus 6? 15 minus 15, that will give you what? 0. You see that? So f of negative 3 equal to 0, right? Right? So how do you define 0? A 0 of fx is a number k such that fk equal to 0. So that means in this case you got f of negative 3 equal to 0. Is that right? So what does this imply? So this implies negative 3 is a 0 of what? Fx equal to x squared plus 5x plus 6. So negative 3 is a 0 of fx. Did you see that? Right? And now similarly, if I plug in negative 2, if I plug in f of negative 2, what will happen? If I plug in negative 2 here, it will be negative 2 squared plus 5 times negative 2, right? Negative 2 is parenthesis, negative 2 squared plus 5 times negative 2 plus 6. And what is negative parenthesis negative 2 squared? 4. And what is 5 times negative 2? Negative 10. And this is plus 6, right? So the 4 plus 6 is 10. So this is 10 minus 10 equal to what? 0. See that? So that means negative 2. So this implies negative 2 is a 0 of fx. You got negative 2 is a 0 of fx. Does that make sense? Yeah. So now look here, guys. So use synthetic division. We decide whether the given number k is a 0 of fx. You know, like, so fx is x cubed minus 4x squared plus 9x minus 6, and k equal to 1. So you can use synthetic division, or you can simply plug in, you know, like x equal to, you plug in 1 for x. It's up to you. Okay? So we have to decide whether k equal to 1 is 0 or not. You have a k equal to 1, and your function is x cubed minus 4x squared plus 9x minus 6. Okay? So you use synthetic, okay? So now you write down 1 here. Or you can simply plug in 1 here, okay, guys? So how do you use synthetic? You have 1 here, so you list the coefficient. So this is coefficient of x cubed is 1, and coefficient of x squared is negative 4, and coefficient of x is 9, and the constant term is what? Negative 6. Is that right? And you bring it down. So what will be this? If you bring it down, this will be 1. 1 times 1? 1 here, right? So what is negative 4 plus 1? Negative 3. And you multiply. What is 1 times negative 3? Negative 3. Is that right? So what is 9 minus 3? 6. And what is 1 times 6? 6. What is negative 6 plus 6? 0. So what did you see that? Now you see that this is a what? Remainder. This is a remainder. So the remainder is 0. Is that right? Right? So what does that mean? So that means 1 is a 0 of fx. 1 is a 0 of fx. So similarly, you can do that. Yeah. Now let's do this one, okay? So decide whether the given number k is a 0 of fx. So your fx is x to the power 4, x to the power 4 minus 2x cubed plus 4x squared plus 2x minus 5, is that right? And your k is 1 plus 2i. Right? So we have to decide whether this is a 0 of fx. So the question is k equal to 1 plus 2i a 0 of fx? So use synthetic, okay? So what is the value of k? 1 plus 2i. So this is 1 plus 2i, and you list the coefficients of the variable, okay? So now you list the coefficient of x to the power 4, which is 1. What is the coefficient of x cubed? -2, right? What is the coefficient of x squared? +4. What is the coefficient of x? 2. And what is the constant term? -5, right? And none of the x term is missing here. None of the x terms are missing here, okay? So what you need to do is, when you want to use the synthetic, you bring down the first coefficient, okay? So you bring it down. Bring down 1. So you have 1 here, right? So what is 1 plus 2i times 1? 1 plus 2i. Did you see that? Is that right? So now you add them up. -2 plus 1 plus 2i. Add them up, okay? So you have a -2 here, -2 plus 1 plus 2i. So that will give me -2 plus 1 is -1. So this is -1 plus 2i. So this will be -1 plus 2i. And then you multiply 1 plus 2i and -1 plus 2i, and you put right below 4. Okay? So now you need to multiply 1 plus 2i, 1 plus 2i with -1 plus 2i. So you see, use the FOIL. So 1 times -1 is -1. 1 times +2i is +2i. Positive 2i times -1 is -2i. Positive 2i times +2i is what? 4i squared. Make sense? And this positive 2i and -2i, you cancel them, right? So you have a -1 plus 4. What is the value of I squared? What is the value of I squared? -1. The value of I squared is -1. So this is -1 minus 4. What is -1 minus 4? -5. So now, so we have a -5 here. That makes sense, guys? We multiplied this and this, and we got -5, and we just put -5 below what? 4. So what is 4? You combine them. What is 4 plus -5? Or what is 4 minus 5? -1. And then you multiply this with this. Okay? So 1 plus 2i times -1. 1 plus 2i times -1. You see that? So it's going to be 1 times negative 1. This is negative 1. Positive 2i times negative 1 is negative 2i. Is that right? Negative 1 minus 2i. So you write below positive 2, right here. So this is negative 1 minus 2i. And now you add them up. Okay, so you add 2 and what? Negative 1 minus 2i. So you add them up. 2 plus negative 1 minus 2i. So this is 2 minus 1 minus 2i. So what is 2 minus 1? 1 minus 2i. So this is, when you combine, you got 1 minus 2i. And then you have to multiply 1 plus 2i and 1 minus 2i. You have to multiply this and this. This and this. And the product you have to put here. Okay? So you have 1 plus 2i times 1 minus 2i. You multiply them, okay? So what did you get? So use the FOIL. 1 times 1 is 1. 1 times negative 2i is negative 2i. Positive 2i plus 1 is positive 2i. So positive 2i times negative 2i is negative. 2 times 2, 4i square. Okay? So now this negative 2i and positive 2i canceled, and you have 1 minus 4. So the I square is negative 1. So 1 plus 4 equal to what? 5. Make sense, guys? Right? So now this 1 plus 4 is 5. You write down here, and negative 5 plus 5, that is what? 0. And this is the what? Remainder. And if the remainder equal to 0, so this 1 plus 2i is a 0 of fx. Right? So the answer is what? Is k equal to 1 plus 2i a 0 of fx? The answer is S. Why that? Because the remainder equal to 0. Because the remainder equal to 0. So you can say that 1 plus 2i is a 0 of fx equal to x to the power 4 minus 2x cubed plus 4x squared plus 2x minus 5. So we got this part, right? Yeah. Okay. So now I want to take you to the next section. Okay, so so 3.3. Okay, now in this slide we'll talk about the factor theorem and we will also discuss rational zeros theorem, number of zeros, and the finding the zeros of polynomial function and so on, okay? So now first of all, let me talk about the factor theorem. So if you have a polynomial function fx, right? So x minus k is a factor if and only if fk equal to 0. So this is a factor theorem. Remember, like, let's say we have a function fx equal to x squared minus 7x plus 12. So this is your function. Okay? And now I want to find out f4. I want to find out f of 4. So what will be this? So this would be, you plug in 4 here, right? So you'll have a 40 square minus 7 times 4 plus 12. Right? What is 40 square? This is 16, is that right? Minus, what is 7 times 4? 28 plus 12. Make sense? And this 16 plus 12, so this is 28 minus 28, which is what? 0. Now look at the factor theorem. So factor theorem tells you fk equal to 0, or you can write this way, x minus k is a factor of fx if and only if. So this is biconditional. If and only if fk equal to 0. So this is a factor theorem, right? Right? Are you guys with me? So this is factor theorem. For any polynomial fx, this is factor theorem, okay? So this is true for any polynomial fx. For any polynomial fx, x minus k is a factor of fx if and only if fk equal to 0. Right? So now look here. What happened here? So this is your fx. What did you get here? f4 is 0, is that right? So you have a f4 equal to 0. You see f4 equal to 0, is that right? So if f4 equal to 0, then x minus what? If fk equal to 0, what will be the factor? X minus k, right? If f of 4 equal to 0, what will be the factor? Look here, guys. If fk equal to 0, what will be the factor? X minus k. If we see f4 equal to 0, the f of 4 equal to 0, is that right? So what will be the factor? X minus 4. Is that right? So x minus 4 is a factor of what? This. That makes sense? And similarly, look here. Let's evaluate f of 3. So what is f of 3? You plug in 3 here, okay? So this is 3 squared minus 7 times 3 plus what? 12. Right? So now that will give you f3 equal to this 3 squared is 9 minus 7 times 3 is 21 plus 12. Are you with me? So what is 9 plus 12? 21. And 21 minus 21, what is this? 0. You see that? So what does that mean? If f3 equal to 0, then by factor theorem, right? According to factor theorem, so what you can say? What you can say? If f3 equal to 0, what will happen? What is the factor theorem, guys? For any polynomial fx, x minus k is a factor of f of x if and only if f of k equal to what? 0. Right? What do you have here? F of 3 equal to 0. So by factor theorem, we can conclude x minus 3 is a factor of fx. Is that right? So what did we observe here? We observed x minus 4 and x minus 3 is a factor of fx. You can check that. Look here. If you have fx equal to x squared minus 7x plus 12, let's factor this, okay? So f of x, so let's factor this. You multiply, the coefficient of x squared is 1, right? So 1 times 12, this is 12. And then you find the factors of 12 such that the sum is what? Negative 7. What are they? What are the factors of 12 such that the sum is negative 7? Exactly. Negative 3, negative 4. So now it's going to be what? X minus 3 times x minus 4. You see x minus 3 is a factor of fx. X minus 4 is a factor of f of x. That makes sense? Okay. Now this is about factor theorem. Okay. Okay, so determine whether x minus 1 is a factor of each polynomial. So you see, if x minus 1 is a factor, then you just need to find f of 1, because the value of k is 1. Is that right? Right? So you find out f of 1. If f of 1 is 0, x minus 1 is a factor. If f of 1 is not equal to 0, then x minus 1 is not a factor. Does that make sense? Now look here, they use the synthetic. Okay, you see that? Your f of 1 is what? 7. Is that right? Right? Are you with me? So f of 1 is 7. So that means, x minus 1 is not a factor. So x minus 1 is not a factor. And now the same thing here. You determine whether x minus 1 is a factor of this polynomial, f of x equal to 3x to the power 5 minus 2x to the power 4 plus x cubed minus 8x to the power 2 plus 5x plus 1. So now use the synthetic. You got remainder 0. So that means what? This is a factor. So let me do this one, okay? This one, we did that one, right? So factoring polynomial with a given a 0, okay? So now let's look here, guys. So we are going to factor fx equal to what? Fx equal to 6x cubed plus 19x square plus 2x minus 3 into a linear factors, and it is given that negative 3 is a 0 of f. Negative 3 is a 0 of f. Okay. So negative 3 is a 0. We know that, right? Negative 3 is a 0. So that means one of the factor is going to be what? If negative 3 is a 0 of fx, so what will be the factor? X plus 3. That is according to what? Factor theorem. Remember the factor theorem. X minus k is a factor of fx if and only if f of k equal to 0. Or in other words, if k is a 0 of fx, x minus k, then x minus k is a factor. If x minus k is a factor of fx, then fk equal to 0. That makes sense? So now this is a 0. So now what does that mean? So if you use the synthetic, your remainder will be what? 0. Right? So now look here. What are the coefficient of a variable? Look at the coefficient of x cubed. This is 6. What is the coefficient of x squared? You have a 19. What is the coefficient of x? This is 2. And what is the constant term? Negative 3. Are you guys with me? So now, if you use the synthetic, what will happen? So you bring down the first coefficient. You know that, right? You bring down the first coefficient. This is 6. What is negative 3 times 6? What is negative 3 times 6? Negative 18. Is that right? So what is 19 minus 18? 1. You multiply. What is 3 times 1? Negative 3. What is 2 minus 3? Negative 1. Right? So what is negative 3 times negative 1? Positive 3. That makes sense? And this is the what? Negative 3 plus 3 is 0. Did you see that? So remainder is 0. So that means f of negative 3. Are you guys with me? The remainder theorem tells you, what do the remainder theorems tells you? If you have a polynomial, right? If you have a polynomial fx, right? So fk is the what? Remainder. Is that right? If the polynomial fx is divided by x minus k, fk, f of k is the remainder. Is that right? So now here, this polynomial is divided by x plus 3. Is that right? Right? So what is the remainder? F of negative 3. And this negative 3 is a 0. What is a factor? One factor. X plus 3. So now you got it. Now, so what will be the quotient, guys? Are you guys with me? This polynomial is divided by x plus 3. Is that right? We got the remainder 0. And what is the quotient? And you see, what is the degree of dividend? 3. So the degree of quotient will be 1 less than 3. Is that right?
So it'd be 6x squared.
Mm-hmm.
And then 1x.
Yes, 6x squared plus 1x means x, right? And then minus 1. That makes sense? And now, remember the division algorithm. So remember the division algorithm tells you fx equal to x minus k times qx plus remainder. You see that? The special case of remainder theorem. A special case of division algorithm. So fx equal to x minus k times qx plus r. Is that right? So now, in your case, your fx is equal to x minus k means x minus negative 3, which is x plus 3. Is that right? What is your qx? 6x square plus x minus 1. This is your qx. And then plus, what is your remainder? Your remainder is 0. Are you guys with me? Right? So now, it would be fx equal to x plus 3 times 6x square plus x minus 1. Make sense? So now this is quadratic. You know how to factor it, right? So this fx equal to x plus 3. Now 6 times negative 1. What is 6 times negative 1? Negative 6. What are the factors of negative 6 such that the sum is positive 1? What are the factors of negative 6 such that the sum is positive 1? I think like this is 3 and negative 2. Is that what you said? Yeah. When you multiply 3 times negative 2, that will give you negative 6. When you add them up, 3 plus negative 2, that will give you 1. Right? Make sense? Okay. So now you can rewrite this as 6x squared plus 3x minus 2x minus 1. Make sense, guys? Okay. So now, you see, your fx is going to be, so this is x plus 3, this is x plus 3, and now from the first two terms, what can you factor out? 3x. Yes, you can factor out 3x. Now inside the parentheses, you'll have a 2x plus 1. Are you guys with me? So now, and from the last two terms, what can you factor out? Negative 2? No, negative. What can you factor out? From the last two terms, from here. Negative 1. Yes, negative 1. And what will be inside the parentheses? 2x plus 1. Are you guys with me? Right? Makes sense, right? So now you'll have fx equal to, so this is x plus 3, and now this 2x plus 1 and 2x plus 1, you can factor out 2x plus 1, and what is left over? Well, what is the remaining factor? 3x minus 1. See that? We completely factored this polynomial into 3 linear factors. Did you see that? Okay. So we did that, right? Okay. Now the next one is the rational zeros theorem. Okay? So if you look at the slides, you can see the rational zeros theorem. Like if P over Q is a rational number written in the lowest term. Okay? And if P over Q is a 0 of f, a polynomial function with integer coefficients, okay, then P is a factor of the constant term and Q is a factor of the leading coefficient. Oh. So now, look here, guys. So the rational zeros theorems. Rational zeros theorem. So you have a polynomial function, and so let's say P over Q, this is given, okay? So P over Q is a rational number in a lowest term, okay? So this is P over Q is a rational number. So this is a rational number in lowest term. So you have a P over Q, and this P over Q is a rational number in a lowest term, and it is also given that P over Q is a 0 of f. So you know the lowest term, is that right? Like for example, if you have a, let's say, 4 over let's say 4 over 20. So what is the lowest term? The lowest term is 1 over 5. You guys know that, right? Right? Or if you have a 3 over 9, so it's going to be 1 over 3. Right? The lowest term. So what are given? So P over Q is a rational number in a lowest term, and P over Q is a 0 of f. And we also given a fx a polynomial function with integer coefficient. Polynomial function with integer coefficients. Okay, so these things are given. Now, what does this imply? If you have all these things given, then you see the P is a factor of the constant term, and Q is a factor of the leading coefficient. If these are given, then what will happen? Then P, this P, the numerator, okay? This P, so the numerator of the rational number, P is a factor of constant term, right? So this is factor of the constant term, and Q is a factor, right? P is a factor, and Q is a factor of the leading coefficient. Okay, so this is rational zeros theorem. Did you get it? You see what I'm talking? You have a P over Q, right, in a lowest term, right, and P over Q is a what? 0 of a polynomial function f(x) with integer coefficients. Then P is a what? Factor of the constant term, and Q is a factor of the leading coefficient. So this is rational zeros theorem. So now, look here. So we want to use rational zeros theorem here, okay? So now let's say we have a polynomial function f(x) equal to 6x to the power 4 plus 7x to the power 3 minus 12x squared minus 3x plus 2. So this is a polynomial function. Okay? So now if you want to list all possible rational zeros, what you are supposed to do is you need to find out the leading coefficient, which is 6. You guys know that, right? The 6 is the leading coefficient. So now here you see the leading coefficient is what? 6. And what is the constant term? And you know the constant term. What is the constant term, guys, here? What is the constant term? 2. Are you with me? Now you find out the factors of leading coefficients. So what are the factors of 6? What are the factors of 6? We are going to list all possible rational zeros. What is our job? We are going to list all possible rational zeros. Okay? So how do we find them? You figure out the leading coefficient, that is 6. You figure out the constant term, that is 2. And then you find out the factors of 6. You know, is 1 a factor of 6? Is 1 a factor of 6? Yes. 2? Yes. 3? Yes. 4? No. 5? No. 6? Yes. So now, you see, you guys know the factors of 6 are 1, then 2, then 3, then what? 6. But you see, these are the positive numbers. So you also have a negative also, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Does that make sense? Right? And similarly, you have a constant term 2. So what are the factors of 2? So the factors of 2 are plus or minus 1 and what? Plus or minus 2. And remember, so P is the factor of the constant term. So these are denoted by what? P. And the Q is the what? Factor of the leading coefficient. So you have, these are denoted by what? Q. That makes sense? Now you find out P over Q. If you look at the slides, I can show you the slides. Look here. So you divide, you know, like, so you divide P by what? Q. Divide plus or minus 1 by plus or minus 1. You will get plus or minus 1. You divide plus or minus 2 by plus or minus 1 by plus or minus 2. You will get plus or minus 1/2. You divide plus or minus 1 by plus or minus 3. You will get plus or minus 1/3. Okay? You divide plus or minus 1 by plus or minus 6. You will get plus or minus 1/6. Do the same thing. Plus or minus 2 divided by plus or minus 1. Plus or minus 2. Plus or minus 2 divided by plus or minus 2. Plus or minus 1. Plus or minus 2 divided by plus or minus 3. Plus or minus 2/3 and so on. Okay? So these are the possible zeros. Okay, I want to stop here. Okay? Yep, I'll see you next time. Okay? Bye.